How's everyone doing? My name's Ryan. Thank you for letting me speak to you about some things that I've been working on lately. The title of my talk is, can you see it? Forecasting Browsers and in the Wild Exploitation. So I want to measure things that matter to me. That's what this talk is about. Risk talks are not often directly actionable. They're often kind of holistic or strategic. I want us to be able to leave this talk with a quantitative measurement of this statement, the likelihood of this statement. That's the takeaway for today. So first we're going to talk about measuring risk. Then I'm going to discuss the dangers of risk measurement. And lastly, I'll discuss how a group of professionals measured the likelihood of this above risk. So this is repeatable, and I'll share use cases that I've used this in as well. So we're going to start pretty abstract, though. Measuring risk. So we're all familiar with how ridiculous risk measurement methods can be sometimes. So we sometimes measure them with crayons. Sometimes we use the word probably. Like a vulnerability is, it's probable, or it will probably be exploited, right? Those are terms that we should run away from. So I want to confront this problem. I want something quantitative to measure something like this. So let's confront this for a second with discussing how do we quantify something simple like distance, right? You'd use a ruler. You'd have a ruler and you'd hold it up to something and say, this thing is this many inches, right? And you'd find that to be a useful measurement because you picked the ruler and you think that rulers are useful, right? So what if you don't have a ruler? You're not helpless, okay? We've all done this. We've all moved furniture. You've moved a couch around a tight corner, right? Or you do the walk. How many feet is this thing, right? So we trust ourselves generally with approximations, and we can approximate the values of things. So we have to accept that. Now, the output of a ruler is inches, okay? The output that will answer our Chrome question is a probability. It's a value between 0 and 1. So we don't have an instrument like a ruler that we could just hold up to the future and say, what's the likelihood of this future thing happening, right? So we have to estimate or approximate the value of that. So to help us get there, this is what's called an odds table that's published by the intelligence community. And they use this to stabilize the words of estimative probability that are used in analyzing intelligence. And this subject matter is very different from qualitative statements like, how much do I love something, or how beautiful is this landscape, right? This concept of estimative probability is fully scorable, it's measurable, and while it is subjective, it is quantifiable. And that bridge is very useful for what we want to do today. So we can measure probability as experts of something by forecasting the probability that a risk will or won't occur. So thus, the expert, which can be us, can replace the measurement device used to measure a future probability with a forecast. Now, so far, with this presentation, I've led you far astray. Prediction is treacherous. It's sometimes measurably useless. So we need to talk about that for a bit. And the subject deserves its own talk, really. This is very compressed. Entire academic careers are focused on the subject of expert judgment. It's generally called decision science, but it often relates risk to this subject area of prediction, and has Nobel Prize winning research, and it's a huge subject area. So we need to beware of expert prediction in a role like this. So I assume that everyone here wants to be good at something. Like you're here to develop, maybe in your security career, you have something you want to be good at. Maybe you want to have, maybe there's something you want to be the best at, for instance. The problem is that your subject matter expertise in something has very little influence on your ability to actually predict things in that space, which is counterintuitive, right? So development of knowledge does not necessarily develop prediction skill, which is very important in discussing risk. So this suggestion is likely because of a few things that an industry like ours just generally doesn't do unless we're pushed to do it. We don't do any form of accounting on the predictions that we make. So we don't keep score of predictions. We avoid time frames on the predictions that we want to make, especially related to risk. And this is how like a rainmaker gets away with fraud, is that a rainmaker will take your money and it's going to rain eventually, but they won't say when. But they'll take your money, right? So oftentimes we're rainmakers. We also use qualitative language, as we said before, words like probability, which in hindsight are always correct, right? I didn't say it was impossible, I said it was unlikely. That's a typical thing that comes from an industry like ours. So there's hope, though. There's methods that make forecasting more effective, that make it useful, and we can mitigate a lot of the issues that I've brought up so far, and that's what we're going to be spending a little bit of time on. So there's 70 years plus of documentation from all sorts of different industries and different subject areas that have tackled the same accounting problem, and they all share concepts from the probabilistic risk assessment, which we're going to be using. So what I've done is I've taken lessons from as many of these fields as possible and tried to find what's common within them. And I have engineer-centric documentation to apply to problems like this. And at a high level, within this are 4 concepts that we're going to discuss: the scenario, the forecast, calibration, and a panel. So we're going to start with the Chrome scenario, which is not hard. We're all familiar with this as well. It's a lot like a tabletop scenario. So when you're talking in tabletop form, we're talking in scenario form. However, we want to precisely define our problem into an unambiguous statement, specifically within a time frame. So as we approach this Chrome problem that I presented, we want to see this observable event, which is whether our group will discover a critical Chrome vulnerability being exploited in the wild in September of 2018. And this is a process that we went through the month before September of 2018, so August. Now, there's qualitative language within that statement that needs to be hardened for judgment. This is how Chrome classifies critical bugs. The critical classification it's a high bar. It's not an easy sort of bug to find. And this is qualitative, but this is labeled within Chrome's bug tracker, which is Monorail, which we'll look at a little bit later. The second qualitative statement that I made, which has even worse footing than this labeling of critical, is this concept of something being in the wild, right? Which we discuss all the time. But think for a second, what the hell does in the wild mean, right? What is the industry definition of in the wild? What is the observable quality of in the wild? So your definition might be drastically different from mine, and that's what I found going down this road, is that you all have different ideas of what in the wild means, drastically different. So we needed, for judgment in this project, to define what is in the wild. Can honeypots be involved? Do lots of victims have to appear for something to be in the wild? You will all disagree on this if you discuss it. Do we have to observe the attack happening successfully for something to be in the wild? Yes? Okay, sorry. I'm pretty loud. That's surprising. Thanks. Okay, thank you. So is this better? Okay, this feels very strange. With this, our scenario is less ambiguous. And if there's anything I need to rehash due to volume, just point it out, please. So yes, without defining this as an industry standard or forming a committee or anything, this was our temporary judgment criteria for this forecast. Not to be anything more than that. So next, given a scenario, we need to structure the outcomes that could result from that scenario that we'll be forecasting. And I'll start with an example. So will it rain tomorrow, right? We're familiar with this one. Yes or no, it will or it won't rain tomorrow. But we could, if we wanted to, make that more complicated. We could say it'll rain more than an inch, it'll rain less than an inch, or it won't rain, right? And that'd be 3 outcomes for that same scenario, or we could just have 2. So for this scenario, will a critical Chromium exploit be discovered in the wild in September of 2018? We just decided to be simple and say yes or no. We see it or we don't. And just like you'd calibrate the scope of a rifle, for instance, you would calibrate experts for judgment of a scenario like this. Simply put, this is just training. It's training experts to be probabilistic in assessments of risk. Now, take the superfans, for example. They're a great example of how this doesn't work. So who do you think the superfans who do the super fans think are going to win on Sunday? I'm so happy I didn't have to say it. So they also think that the Bears are going to win the Indy 500 and the Preakness, and they're never wrong because their excuses are fantastic. Everything is always a win for the Bears, right? So they cannot be helped. They're out of the picture here. But let's take non-fictional professionals like yourselves as individuals here, and what if we were to confront you over time with the outcomes of all of the predictions that you make, right? You would be training and developing as an expert, and you would start avoiding statements like the Bears are totally going to win, right? You would start saying things like maybe the Bears have a likelihood of 67% chance of victory, right? And you might start relying on things like an odds table. You might develop a model based on historical data. You might find non-Bears fans, non-super fans to have an objective person to bounce your ideas off of. And these sorts of things are prediction skill as it develops measurably, because this is measurable over time. Now, that said, we can't train bias out of you. So we can train people to be better at prediction, but we can't eliminate bias in an individual. So to solve that, what we do is we drown out that bias with a panel of individuals who have bias, but are biased differently, which helps us drown out anyone with a significant the Bears type bias by just having others to balance that out with. So what I did is I built a panel of 15 individuals in security. It included engineers, managers and directors, CISOs, CISOs, I don't know how we all pronounce that now, journalists that cover the security beat, male and female. They were junior engineer to staff engineer. They were varying in prediction skill, and some of them being calibration trained, as I discussed, some of them not. So with that, so far I've only been describing the process of the infrastructure of a forecast and building a forecast. But now I want to move into what did the panelists think about in developing an answer for this forecast. So we started with Monorail, which is the repository of bugs for the Chromium project. And at the time that this forecast was being developed, there were 126 critical bugs ever found in Chrome, over 100 months of Chrome's existence. On average, there were less than 3 of these critical bugs that would ever appear in a given month. And about 10 bug bounty payouts per month to bug finders in Chrome, and about less than 2 CVEs that met critical severity in any given month. So the point here being is that critical bugs on a regular cadence find their way to the Chrome developers, right? However, as you probably have reasoned already, finding critical bugs does not necessarily mean that they're going to show up in the wild being used by criminals. They're completely separate things. In fact, the panel that we put together had difficulty even remembering a single critical Chrome vulnerability that was ever exploited in the wild. And you might have trouble thinking of this too, and we searched extensively, and we have not found that example. So we thought, is this such a rare thing that it hasn't happened, or is it so rare that we haven't observed it yet, right? So we asked Chris Evans. He founded the Chrome security team, and he let us know that there weren't any in the wild full Chrome critical exploit scene while he was at Google. Additionally, I doubt there have been any since, because the team is very transparent and it would be a big deal, and I would agree with him on that. Additionally, however, no one sane really doubts that the top-end governments have critical exploit capability against Chrome. So we found that conversation to be very informative. A weather forecast. That's appropriate. That's on topic. So this lended a strong opinion that was similar to ours, that there could be in the wild exploits in the future, but they're rare, but they're not ruled out entirely. So we felt that we were in this realm of predicting a black swan. It's falsifiable, but it's indeed rare. So one of our last steps here was to build an odds table, and this is similar to the CIA odds table that I showed you earlier, but more calculated towards the problem that we're trying to solve. So this is the probability of something happening per month and what it would look like per year. So if you believe that something has a monthly likelihood of happening, what would that end up looking like in years frame, in a year's time frame? And this is to help with estimation. It's not a guarantee that things happen with this relationship. It's more or less just an estimation tool. So for instance, if you believed that something happens every 28 years with a monthly likelihood, then that monthly likelihood would be close to 1/3%. And that's just a simple way of representing one versus the other. So all of the concepts that we've talked about so far are baked into a tool that I maintain to collect panel forecasts. And at the bottom of the tool, there's a what is your percentage belief of something happening, yes versus no. And while a tool like this is useful, you can do this on a napkin. You can do this in a spreadsheet. A tool is not necessary, and nothing's being sold today. This is open source, but I'm only releasing it because it is so broken in alpha right now to individuals that ask. So if you want to have access to this repository, I'm happy to share it. There's a demo up at e6e.io if you want to mess around with it. Also, it's alpha, so don't expect your data to stay there. But it's a place to look at where you can do something like this. So, drum roll, the average result from this panel that estimated the likelihood of will a critical chromium exploit be discovered in the wild in September of 2018 came through at 1.65% yes, which translated with an odds table is expect one in the wild exploit every 4 to 6 years as an expert panel belief of that likelihood. So one of the biggest debate points was political climate. So in September and the month before, several things were going on. Brexit was ongoing, midterm elections were coming up, and there was increased military activity as well. And some of the panelists thought that that individual month's likelihood should be higher as a result of that activity, maybe dislodging an O-day from a weapons store somewhere. Other panelists strongly disagreed with that and felt that political climate is a near constant month to month, and a scary month shouldn't increase the likelihood of that. And you might have opinions one way or the other yourselves. But the thing is that you don't have to agree, right? These panelists didn't have to agree on that specific subject, and they didn't have to talk about it to death. They just had to express a percentage belief about this. So that there was no agreement necessary, but we still have consensus through an average. Across all of these beliefs, all of these land within the once in years time frame, so it's still informative to us. Now, after September of 2018, we were able to score this by seeing, did the judges observe in the wild exploit activity of Chrome? And we didn't. So we get to apply a score to this, which is basically an error of what the forecast result is based on the real outcome that you see. And this is called the Breyer score, and without getting into detail, it's a squared error of the forecast. It's very simple. So, how is this useful? What is the use of this? Well, things change expert opinion. Your opinions are fluctuating day to day with conferences like this. So for instance, if the expert panel were to hear that Chrome has improved their sandbox, then this would reflect itself with variations in their forecast. Or on the other hand, if there's research that comes out that says that sandboxes are easily bypassed, that would also change this forecast. But yes? What would be useful for you? Yeah. So honestly, I have debate about usefulness of this stuff in general. I'm trying to make this a very pro-forecasting talk, but there is questions about when does this make sense to do and who the audience would be. But if you specifically needed to know this, then you just do it as often as you would need to, and you fluctuate some of these variables as you need to. So additionally to change in Chrome, you can compare it to other browsers. So we also forecasted Firefox recently as well, and this is actually expiring today. So hopefully there's no O-days in Firefox exploited today. So Firefox, though, as opposed to Chrome, does not have black swan events for exploitation in the wild. It's happened frequently in the history of Firefox, even when its sandbox was being developed. So there are several I think it was recently as 2016 and 2015, they had emergency in the wild patches as a result of emergency in the wild exploitation due to critical vulnerabilities. So the structure of the forecast is nearly identical for both browsers. This ended up, I don't know if it showed there. So this came out to be, I think, once every other year was the sentiment of this expert panel. Now, these browser examples have really good historical data to work with, but we should be able to do this for new categories of vulnerability as well. Yes? Right. There's a lot of legalese that we left out of the decision making, but plugins were not. They don't trigger critical vulnerabilities unless it's part of the extension. I think they call it. I don't forget the Chrome word for this, but we didn't include like a malicious plugin in this example, right? And there were some other conditions too. Firefox is much more complicated with like Tor browser and things like that, but you have to define that up front. That's the goal of this. So that said, NetSpectre is a family of vulnerability that doesn't have a huge, rich history of in-the-wild exploitation that we can draw from. But we still have to make decisions like, do we patch this now? do we drop everything in patch? So we have to be able to forecast things like this as well for patch urgency. So NetSpectre was one of the variations that the network version of Spectre when the Spectre and Meltdown issues were published. And for this, the panel that we put together believed that NetSpectre would not be exploited immediately, right? There's a much higher likelihood that this would, from the time of publication, it would be months out before we see any in-the-wild attacks as a result of things cited to be NetSpectre. Now, we can compare this very easily with something much scary, and we were able to score this as well. We were not able to find any examples of NetSpectre being exploited in the wild, and that received a Breyer score that was low as well. So compare this with struts, right? We've all been burned by struts. I've personally worked incidents where struts is the root cause, and we're walking away from Equifax recently as well. And there was another struts vulnerability that showed up last year that we also measured. And what we did was we had to make special categories for early exploitation because of the belief that it could happen immediately. And the panelists assigned nearly all of their likelihood into the week after the announcement. And that's actually what ended up happening is struts was we immediately saw exploit attempts in the wild for this new struts vulnerability. I think one of the first leading indicators of that was a gray noise tweet. I think the gray noise team is here. Can't hear me anymore? Okay. So yeah, like I said, struts had in the wild exploit activity almost immediately after the announcement. Very different from what we saw with NetSpectre. So what we have is a way to take completely different bugs, different platforms, different exploit techniques, different everything about them, and compare them based on what the in-the-wild activity would look like, which is informative for something like patch urgency. Yep. I think it's smart to keep it consistent, but there's workplace realities like I quit. Oh, I'm sorry. What is the benefit of having a consistent panel or a fluctuating panel? Is that a good? What would I recommend? Okay, I would recommend a consistent panel of trained individuals. As an example, I ran a panel at Enigma just a few days ago, and my observation on that was that I would much rather have calibration trained panelists, and I think more than a couple is informative for a tough question. Although I do think that an individual without a panel is useful if they're calibration trained and if they're probabilistic about how they reason through things. So I would rather it be consistent. So that's my presentation. So we've discussed probabilistic risk, the dangers of humans estimating risks, tools that are useful in measuring risk, and several use cases that we can compare with each other about in the wild exploitation. Thank you. Happy to answer questions, yes. Absolutely. Well, the first point to make, I think, is that not everything needs a panel. I mean, I'm really trying to maximize what high rigor panels look like, so I know when they're useful. But day-to-day work does not require that. So I think there is a measure of how useful is this decision, and what should I bother gathering all this rigor together. Other than that, the other aspect of this is that forecasting is useful when you are missing lots of data. So the without a history of data, without rich data to model things from, the role of forecasting is really powerful in that position. But if you have lots of data, like let's say highs and lows for the last 30 years of temperature, the meteorologist in that role isn't applying a lot of subjective tweaking to that final result. They really trust a model. So very data-informed situations will have a diminished forecasting role, but something like NetSpectre, like we've never dealt with this before. What do the experts think? That's when you really stand this in. So I think those are the two things that come to mind. Any other questions? Oh, yes. Right. So when I have a ruler, what do I do? Is rarely a question you ask. Generally, somebody says, I have a problem, and then you think, I need a ruler, right? So in a case like this, somebody would ask you a tough question, right? You would already be asked by your management or somebody else to figure something out. And then this would be the tool that you use. So often it's difficult to think of this in reverse, which is, wow, this is really cool. Forecasting and panels are awesome. Now what do I do? And you're gonna fall short. But when somebody comes up and says, how bad is NetSpectre? Like, let's get a panel. And now you're already driven to make a decision with it. You see what I mean? Yeah. Yeah. This is something that I feel. Right. I'm actually very against putting money on forecasting, and I hold a weak opinion on that. So like you could what. Do you pay your local meteorologists based on how often they are correct with their forecasts, or do you trust them to do their job? Okay. I wore pants today because the meteorologist said that it's going to be relatively cold. So I trust them, and you're all wearing pants too. So believe it or not, you can pay someone to do a good job. You don't have to make everything a bet. Yeah. A flat fee. Any other questions? I was so happy when I saw the logo for those. I was like, I'm forecasting this immediately for exactly that reason. And the question being, did I forecast, or did we forecast these because of the disparity in hype? I guess hype and actual exploitation criteria. Yes, absolutely. Oh, I'm sorry. We didn't get to that one in time, but we caught NetSpectre, which is even more, my understanding, even more complex exploitation criteria on top of Spectre itself. But yeah, to be able to trivialize it almost into, do I got to deal with this today? That was the usefulness of it. I don't even need to know the internals of it if I have a panel that can help me out with that. That was the last question, so thank you so much.